I am Meghna Parikh, and today we are here to start the lecture series of Mathematics-02. Our chapter is Laplace transform. Lecture number 12, partial fraction case 3. In last two sessions we have discussed about the partial fraction case 1 and case 2, where partial fraction of case 1 and case 2 are depend on the linear roots and partial fraction case 3 and case 4 are depend on the complex roots. So let's start the topic, method of partial fraction, where case 1 and case 2 and case 2 are depend on linear factors and case 3 and case 4 are complex factors. 1 upon s square plus as plus b, this is the complex form or quadratic form. Similarly, it is s square plus cs plus d, this is also quadratic or complex form. We are assuming as plus b, s square plus as plus b and plus cs plus d upon s square plus cs plus d. Example, find the inverse Laplace transform of the 5s plus 3 upon s minus 1 s square 2s plus 5. First of all, applying Laplace inverse 5s plus 3 upon s minus 1 s square 2s and 5. Okay. Now we are assuming a factor like s minus 1 is a linear factor, so we are assuming a only. And s square plus 2s plus 5 is a quadratic root, so we are assuming for that bs plus c. So this is a combination of the case 1 and case 3. It is our equation number A. Taking LCM, we get 5s plus 3 equal to A s square plus 2s plus 5 plus bs plus c into s minus 1, equation 1. So, we get 5s plus 3 equal to 2a s square, sorry, it is only s square, 2as plus 5a plus bs square minus bs plus cs minus c. Okay. Now, in this method, we are comparing a coefficient of the highest power of the s. Like, first of all, we are comparing coefficient of s square. We have a square and b square. In the left hand side, there is no term of the s square. So, equation is a plus b equal to 0. Equation number 2. Now, comparing coefficient of s. Left side 5, here is 2a minus b plus c. Okay. So this is equation number 3. Next, we are comparing a constant 3 equal to 5a minus c. 5a minus c. This is the equation number 4. Now, first equation is a plus b. We are convert from equation 1 a plus b equal to 0. So, b equal to minus a. From equation 4, sorry, it is equation 2. From equation 4, c equal to 5a minus 3. Okay. Put these two values in equation 3. What is equation 3? Equation 3 is 5 equal to 2a minus b, 2a minus b plus c. 5, 2a. What is the value of b? b is minus a, so it is plus a. What is the value of c? c is 5a minus 3. So we get 5 plus 3, it is 8, 2 plus 1 and 5, it is 8a. So a equal to 1. Okay. Now if a equal to 1, b equal to minus 1, then c equal to 2. Okay. This is our value of the undetermined coefficients. Put this value in the equation A. Our equation. What is the value of A? A is 1. What is the value of B? B is minus 1. C is 2. Now find the Laplace inverse of these two equations. So Laplace inverse of these e raised to t plus Laplace inverse, we are taking minus common. First of all, we write as it is 2s plus 5. Okay. Now we are taking minus common, so it is s minus 2. S square plus 2s plus 5, we are set the whole square form, s plus 1 whole square plus 4. So answer e raised to t minus Laplace inverse. In numerator, we are set s plus 2, denominator s plus 1 whole square plus 4. Okay. Plus 2 or plus? It is so e raised to t minus Laplace inverse of s minus 2 s plus 1 whole square plus 4. In next step, we get e raised to t minus Laplace inverse s minus 2 s plus 1 whole square plus 4. E raised to t minus, we are formation to take the set, there is s plus 1, so we take s plus 1 minus 3 s plus 1 whole square plus 4. E raised to t minus Laplace inverse s plus 1 upon s plus 1 whole square plus 4 minus 3 upon s plus 1 whole square plus 4. Applying inverse first shift theorem, e raised to t, we are taking e raised to minus t. So we get Laplace inverse s upon s square plus 4 minus 3 upon s square plus 4. Next step, e raised to t minus e raised to minus t s upon s square plus 4. So answer is cos 2t plus 3 by 2 sin 2t. So this is our last answer of this example. Again, we recall the examples. See, in that case, there is a two type of the equations. One is a case 1. So we are applying for this case 1. This is a case 2. case 3. So we are assuming a upon s minus 1 plus bs plus c upon s square plus 2s plus 5. This is our actual equation. So we say that it is a equation A. Now taking LCM, we get 5s plus 3a s square plus 2s plus 5 plus bs plus c into s minus 1. This is our equation 1. Comparing coefficient of s square and constant, we get the three equation. One is a plus b equal to 0. Second one is phi equal to 2a minus b plus c. Third one is 3 equal to phi a minus c. That is the fourth equation. Now, from the equation 2 and 4, we are convert as a value of b in the A formation and at the value of c in the A formation. So, we use these values in the equation number 2. Okay, what is equation 2? Equation 2 is this. 5 equal to 2a minus b plus c. 2a, value of b is minus a. Okay, value of c is 5a minus 3. Put the value, we getting a value. If a equal to 1, so due to b equal to minus a, b equal to minus 1. Putting the value of a here, we get c equal to 2. Put all these values in the equation. A equal to 1, b equal to minus 1, c equal to 2. We get 1 upon s minus 1. Inverse of this formation is simple. It is e raised to t. So this is your answer of the first equation, e raised to t. Now it is minus s plus 2 upon s square plus 2s plus 5. This is the formation of the partial fraction type of the formation, and also it is an inverse first shift theorem. So we are solve this example using inverse first shift theorem. First of all, we are set the formation of the whole square in the denominator. What we do, s square plus 2s plus 1 plus 4. So it is s plus 1 whole square plus 4. In numerator we get s minus 2. To set the inverse first shift theorem formation, we have compulsory to set s plus 1 in the numerator. So we taking a minus 2 formation as a 1 minus 3. We get s plus 1 minus 3 upon s plus 1 whole square plus 4. Now taking individuality, s plus 1 upon s plus 1 whole square plus 4 minus 3 upon s plus 1 whole square plus 4. Here we are applying inverse first shift theorem. Due to inverse first shift theorem, we are convert s minus a to s. To convert s minus a to s, we are taking a common e raised to minus t. So it is e raised to minus t, s upon s square plus 4 minus 3 upon s square plus 4. Applying Laplace inverse, we get last